Welcome back to my channel, everyone. Sri Tips here. And a couple years ago, maybe it's been a couple years, I bought a fine silver coin online. I thought I was getting 10 individual silver coins, when in fact I didn't read the listing correctly, and they sent me a single 10 troy ounce silver round. This is it. I had seen fake ones like this, so to prove to myself that it was in fact silver, I filed a little corner off right there and put some Shorter's testing solution on it just to make sure that it was in fact silver, and it was. When I tested this coin, it created an uproar among some of my viewers that I had ruined this coin and destroyed its value. And you have to understand that this coin is just silver, and it only has any kind of additional value above and beyond its silver content if you assign it that additional value. To me, it's just silver. So today what we're going to do is we're going to dissolve this silver coin in nitric acid and make some electrolyte for my electrolytic silver cell. Here we go. Keep in mind that I bought this coin specifically to demonstrate that this kind of stuff, this kind of silver, can be used to make the electrolyte. It weighs 311.7 grams. That's 10.020 troy ounces. I consulted a source that is yet to fail me, the goldrefiningforum.com, and I looked on there, and a fellow user on there says it's going to take 1.22 milliliters of 70% nitric to dissolve this coin completely. So we're going to have 380 milliliters of concentrated nitric acid for this reaction to be complete. We're going to start by placing the silver down into a 2-liter beaker. And now I'm going to add some distilled water here to about the 600 milliliter level. Now what we'll do is turn on the stir bar down in there, get that thing stirring. And what I'll do is I'm going to charge up an addition funnel with some nitric acid here. $200 milliliters. Now I'll add the nitric acid to this funnel. Make sure I got the stopcock off. I'm going to add another 150 milliliters of nitric acid. So we'll have a total of 350 milliliters of concentrated nitric acid in with our coin. See if we can get it all to dissolve. I want a little bit left when this is complete. I want a little bit of undissolved silver left in there to ensure that we've consumed all of the nitric acid. Now we'll add the nitrate to our ring stand here. Get this set up for delivering the nitric acid into our beaker. I'm going to reach up there and take the lid off before we get started. I've got a delivery tube here that I want to install on the apparatus. Now I'm going to carefully adjust for a slow drip into the reaction beaker here. We're going to dissolve this coin, make some electrolyte. I'm going to add some heat now. We'll just let this heat up and react. And we're going to make some electrolyte for the electrolytic silver cell out of this 10 troy ounce silver coin. If you notice the setting on that hot plate, I've got it all the way up on high. I could not get that solution to boil, so I decided to take the coin ware dish off and set the beaker directly on the hot plate. And as soon as I did that, there was enough heat transfer, the solution started to boil. I got the beaker setting directly on the hot plate now. Took away the ceramic dish that it was sitting in. Now, if you notice, there's some trash floating around in there. Not quite sure what that is. That came out of the coin. I don't know about this stuff, man. The solution looks awful yellow, but there is still some nitric in there, I think. I can tell because there's some fumes up here. So I don't know about this, man. I don't know what to tell you about this. I didn't expect to see trash in a nice coin like that. You can clearly see there's some junk down in here. Looks like there's still some nitric acid in here. What I'm going to do is take a little bit of the silver crystal from my silver cell and put it in here a little bit at a time and see if we can get oh boy, look at that. There's a ton of nitric in there. So 1.22 ml of nitric for every gram of pure silver is a little bit too much, I think. I'm going to have to keep putting in small amounts of silver until I get the rest of the excess nitric in this solution used up. Shouldn't be that much more than there should be, but just slowly add the silver crystal in, and this should consume the excess nitric that's in there. All right, I cut the heat back. I'm going to add a little bit more pure silver crystal from my silver cell. And we're going to dissolve this. We're going to add the crystal here to make sure and use up all the available nitric acid that appears to be still present in our solution. I do not like the looks of that trash that's in there. Not quite sure what that is. I don't know what to tell you on that, man. That came out of their coin. Not quite sure what that black stuff is. I just add the silver and then start dosing it with nitric acid. until I've got everything dissolved, the fumes are all gone, and I've got a little bit more, a little bit silver left in the bottom of the beaker there. That's what I'm hoping for here. While I'm waiting for that reaction, I've been tasked by Mrs. Three Tips to get some more silver pieces listed. And so I'm going through and checking each of these pieces, making sure that they're actually silver. I've got too much. It's all piling up on me. And so I'm going to have to go ahead and make up another quick batch of stuff to sell, to list on my eBay store. Once I get the pieces tested and I'm sure that they're silver, I take them over here to the ultrasonic. We give them a bath in the ultrasonic cleaner. And once I get these things all cleaned off in the ultrasonic, I will rinse all the soap off of them. Then we'll run them over here to the steamer and steam them off real good. That should kill any bacteria and sterilize the pieces. And we hit them with the blow dryer. Total weight on this jewelry lot is 1,031.3 grams. And now what we'll do is we'll lay this all out nice and neat so you can see each individual piece. These have all been tested and verified silver. I don't know what these stones are here, but this stuff is just too nice to scrap out. So I figured I'd go ahead and get it all cleaned up and get it listed. It's got some writing on it, not sure what that says. There's a butterfly with some nice implements on it. I don't know what this is. It might be turquoise, not sure. There's a cross, a little slide thing for your necklace. Not sure what that is. Made out of silver. Here's some pieces. Looks like that might be man-made. Nice stones in these pieces. This one's got a maker's mark on the back. This has got some, what do you call it, hematite. A couple of those might be missing. When I put it through the cleaner, I did see some come off. But these are all nice pieces, too nice to destroy. So I figured we'd get them listed. This has got some brass on it now. Signed by the maker. This is some kind of ceramic piece made out of silver. That's a nice flower with a pearl in the middle. Made out of silver. I think this is lapis. Some other kind of stone up here. This looks like it's a man-made stone. And then we got these long chains here. This is an anchor chain necklace. It's nice and chunky, nice and thick. It has a bracelet that goes along with it. Then over here is some beaded necklace, fairly long. Here's gold over silver necklace. Nice solid piece of silver. Not sure what this is. It's a red stone there, but it is silver. Here's a multicolored bracelet. Here's one with some, this has got diamonds in it. I think they're low quality diamonds, but it's got diamonds in it. This is CZ. This is CZ. This is malachite. More CZs. Here's some more beads. These are sapphires in silver, gold over silver. These, I believe, are synthetic opals. Some more beaded pieces here. Toggle bracelet. This is lapis. And I'm not sure what kind of stone that is. That's a solid silver piece plated with gold. And we've got these long, what do you call those, San Marco necklace and matching bracelet. Alright, I'm not sure what these stones are. Everything's in good shape. These are diamonds. I tested those. You normally don't see diamonds and silver, but there you go. I tested those. Those are diamond. These are CZ. And these are pretty nice. These open up like so. I got a mark down on the bottom down there. See that? And each one is marked the same. Enamel on the surface there. These are very nice. Too nice to destroy and scrap them out. It's a nice piece there. I don't know what this thing is. Looks like Greek heads. Made solid silver. Nice chunky piece. Here's another piece that opens up with a hinge. Very nice. And then I don't know what this is. Multicolored stones. Pretty neat looking. I think that's going to be black onyx and a solid silver piece. Not sure what this is. Looks pretty good though. Very nice. Set in solid silver. Last but not least, I think these are going to be lapis. Blue lapis stones. Looks Native American with feathers. Earring set. Here's a twisted earring set here with wires for the ears. This is going to be turquoise. It too looks Native American. Back here's another set of turquoise earrings. Over here I've got some cameo earrings. Now these have some hematite pieces missing. But other than that, they're in real good shape. Solid silver. Here's some more Native American looking pieces with turquoise. I'm not sure what that stone is. It's silver. It's a nice ring. Too nice to destroy. This one says made in India. Verified and tested. Not sure what that stone is. And that's it. That's it for the jewelry lot. If you are the winning bidder on this lot of silver, I will be shipping each piece individually in a bag so that they all stay nice and clean and separated. And we'll ship these priority mail in a flat rate medium-sized box. So each piece will come individually wrapped, and it's all being cleaned and sterilized. Let's get back to our electrolyte and those reactions out in the fume hood. I'm going to take and dissolve some more silver here. This will be some silver from my silver cell. I'm going to try about 200 grams here of silver from my silver cell, and that should give us about 550, 600 total dissolved silver for the electrolyte. That's close enough, I think. 200. All right, I'm going to add some distilled water to about the 300 milliliter level. And then we're going to add a little bit of nitric, no heat, and we're just going to let this start to react with no heat. Alright, that was about 175 milliliters of nitric acid that just went in. Having a whole bunch of excess nitric in the electrolyte will cause problems in the silver cell, so that's why we want to make sure that we've consumed as much of the nitric as possible. I've almost got this complete, but what I want to do is ensure that I've got plenty of excess silver in here and that all these fumes are completely gone. That way I can tell that all the nitric has been consumed when I got a little bit of silver left in there and no fumes. This is the 200 grams of pure silver crystal, and I couldn't get this to boil either, so I had to remove the Corningware dish and set the beaker directly on the hot plate, and then it began to boil. You see right there, I just added some more pure silver crystal. I had to continually add more and more crystal to consume all the excess nitric, and here you can see the solution is colorless like water. This has taken about 8 hours. I'm right exactly where I want to be now. You'll notice that this one has evaporated off quite a bit. You got to watch out. You can scorch this. So you got to watch out. You don't want that liquid level to get too low. So I'm going to turn the heat off now. I'm going to let this stir. I'm going to add a little bit of water here. Help cool it off a little. Same with this one. I'm going to reach in here and get this back out of the way. Let's see if I can do this. Make some room. I'll move this one down off the heat. And get this thing out of the way. I've got a Wapman number 42 filter paper in here. Those seem to do an excellent job of filtering fine particulate. Now what I'm going to do, this is the beaker that had the coin and has a little black debris in it. So what I'm going to do is I'm going to filter this one first because it's the cleaner of the two. So what I need to do here is grab the stir bar. Just going to filter this solution now. Let me grab it right here before I have a mishap. I'm going to pour it right through the filter. Should go very quickly because there's going to be 0 solids in here. Now we're going to do the silver nitrate from the coin that we dissolved. Let me get the lid first. Grab this. just pour it right through the filter now. This highly concentrated silver nitrate, as it evaporates, it starts crystallizing out a solution there. You can see it happening right on the inside of the beaker. Notice how clear and colorless this solution is. I think this would be okay to use. Some fine silver coins to make electrolyte. You don't have to have fine silver crystal. You can use these silver coins to make your electrolyte. Here's a look at the filter. Very little, if anything, filtered out of those solutions. The solution is clear like water. I'll combine these two into one beaker. We'll add some more distilled water, some more nitric, dissolve it, and then use this to augment the electrolyte in the silver cell. Okay, these are my used silver cell filters, and kind of building up on me. We're going to have to do a video on how to refine the precious metals that are in these filters here. In the meantime, I'm going to clean this basket up and get it ready to operate the cell. Here's our filter basket. This is the filters that I use in the cell. I got these at Ace Hardware, and they're just Dacron filter bags for a vacuum cleaner. What I do is I turn them inside out, make sure none of the seams are in the way, the tags out of the way. I stick it on the bag here, and then I use a empty paper towel roll and push it down into the bottom. Next, I use my chin to hold this thing in place, and then I fit the retainer, which is just a lid of one of these little plastic Tupperware containers with the top cut off. Next, I take a sharp razor, and then I go all the way around this thing and just trim off all of this excess material all the way around. This is impure silver shot, about 98 to 99% pure. We melted it up during the furnace build, if you remember that, and poured it in water to make those granules. You can't use sterling silver here. It's got to be about 98 to 99% pure silver. If you tried to use sterling silver, what would happen is the electrolyte would quickly become fouled with copper. This is the actual cathode of the cell. It's a 3.5 liter stainless steel bowl. I think I bought this thing 10 years ago at Sears. It's got a little rubber coating on the bottom to hold it in place. Alright, for the top, this is just a cutting board that I cut the middle out of it. I traced out a circle. This is the same size as our bowl back here. And then I drilled 4 holes and put little pieces of bamboo skewer in there so that it can be located centrally over the cell, like that. Here's our electrolyte that we just now prepared. And what we're going to do now is add the electrolyte to the cell. Just going to pour it right into the stainless steel bowl. Now we're going to dilute the solution with some distilled water. I just pour it right in and then stir it up. And we'll stir it up. Make sure we got it mixed up real good. I'm going to connect the negative leads from the power supply to the perimeter of the bowl now. Here we go. Let's put the top on and install our anode filter. And I just leave this glass rod right in there so I can stir it occasionally. I'm going to cover up the entrance here so we don't have anything falling down in there. I've got a specially prepared anode electrode bar here. I'm going to set that right on top of the impure silver shot in the anode basket. Now I'll connect the positive side of the power supply to our electrode bar here. Now we're going to turn our power supply on and see what we get, what kind of readings we get here. Here it goes. I'll adjust it for about 3.5 volts. We just started the power supply, and if you look down in here, don't quite see any crystals growing right off the bat, but we'll come out here in a few minutes and look back down in there, and you should see some pure silver crystals starting to form on the inside of that stainless steel bowl. This is an hour and a half's footage, time-lapsed, and what's happening here, you can see the silver crystals starting to form on the inside of the stainless bowl there. What happens is the electric current dissolves the impure silver shots that's in the anode filter. It passes through the electrolyte and then plates out on the inside of the stainless steel bowl. It is the following morning, and our amps and voltage looks good. And if you look down here at the cell, take a look in here, you'll see that the pure silver crystal has coated the bottom of the stainless steel cell. I keep the viewing port covered up with a piece of paper towel. Now what we're going to do is we're going to take some of our impure silver here, and I just pull the anode bar out, set it off to the side, and now we'll add some more impure silver shot into the anode filter basket, and then we'll replace the electrode bar. And if you look up here, our amperage is about 1.7 amps. The cell will crank out pure silver crystal at the rate of about 5 troy ounces per day, and it takes about 10 days growth before I have to shut the cell down and harvest the pure silver crystal. This will wrap it up for this video. I think I've demonstrated that we can use pure silver bars or rounds that we order online, dissolve them in nitric acid to make our electrolyte. We do not have to have pure silver crystal in order to make the electrolyte for the silver cell. And just a little comment about a couple things here. The trash that was in the coin that I dissolved, I'm not quite sure what that was. It was a black material, and I don't think it harmed the process. We could filter it out easily, and the electrolyte from that coin was clear and colorless, so I think it'd be just fine. And the other thing I'd like to point out is a few weeks back I had a problem with my silver cell, and I couldn't figure out what was going on. It was producing funny looking silver crystal. The amperage was way high, 2.7, almost 3 amps going through the cell. And I cleaned that cell out, and I went to cement out the silver from the electrolyte with copper, and I got a whole bunch of heat and red fumes. So what that means is I had a whole bunch of excess nitric acid in the electrolyte, and that is what was causing the problems. I don't know how it got in there, but I was able to solve it by making sure that I keep the free nitric in the electrolyte down to a minimum. This will conclude the video. Thanks for watching.